right, so you have that. You ready to go?
Sure.
All right, Gil.
Thank you. Good morning. Ooh. ESM loaders. This is going to be a talk about ESM. Actually, most of my talks at NodeConf were about ESM. It's near and dear to my heart. I've been following ESM and loaders roughly since the beginning when they started implementing it. Yep. It worked in the morning. Let me, there's going to be a slide on it, but I'll move it a bit forward. I know there's a lot of controversy about ESM. I had a like for all you ESM haters out there, and like a derogatory slide, but I removed it for code of conduct reasons. But I do want to say that I truly believe that ESM is the right way. The way ESM was implemented in Node.js was the right way. And instead of choosing what for me was a myopic implementation that would have benefited Node.js compatibility, the modules team chose something that is panoptic and benefits the whole JavaScript ecosystem. I think they did a wonderful job. I know that there's going to be pain, and there is pain, but it will be a few years, and that pain will go away, and we will get the benefit of a one.js system. Just like the web, like Node.js is becoming more web interoperable. From my point of view, this is part of that interoperability. Thank you. Hi, I'm Gil. 30 years, Tali talked about 30 years of experience. I was her instructor in the Army, so 35 years. I'm probably one of the older ones here. I go way back to the 80s, working as a principal engineer in Microsoft. And on a really very small personal note, I come from Israel. My son is in reserve duty there. I pray for his safety. I pray for the safety of everybody from the river to the sea. And I really, really hope, and I'm optimistic that out of this dire circumstances, a good solution will come for all the peoples involved in this situation. Thank you. Okay, warning. This is going to be a really boring talk. Seriously. Most of my talks are a bit lighter and jokes and everything. I'm going to, like, lots and lots of code, so pay attention. I'll try and keep it, like, nice, but heavy, deep technical and stuff inside. But I guarantee that if you follow, you will know how to write ESM loaders and know how to modify the module loading in Node.js. And you will see that they also did a good job in module loading. In the module loading API, it's really, really simple and very, very powerful. There we go. There. So let's get a few things out of the way. What is ESM? Okay, ESM is the standard JS module system. This is CommonJS. Module exports on one side, and on the other side require. And ESM uses standard JavaScript syntax, import and export, to do modules. I'm sure all you know. And as I said, we talked about that. I'll skip that. And what is module loading? Okay, what does that mean, and what does enhancing it mean? Let's talk about what module is. A module in JavaScript, and I love it, is a glorified file. Okay, it's just a file. File equals module, module equals file. And what is module loading? It's glorified execution. Okay, if you think about it, if I do node and give it a module, I'm just executing the JavaScript code inside it. So module loading is glorified execution. But if you import a module, that's still module loading. You get glorified execution with binding between the imports and the exports. Okay, that's about it. When you import a module, you're executing the module, and you're creating a binding between the imports from the importing module to the exports in the importee module. And I'm not going to go into the whole thing. I have talks about how ESM really loads everything, but it goes through 4 phases, and the first 2 phases are the most important. First of all, when it gets a specifier, like import from something, it resolves that something using the parent URL, using the URL where the module that is importing is. And ESM does not use file paths. It uses URLs. But those URLs are file, colon, / URLs, so we're still in the file system. Once it resolves, and we'll talk about resolution later, once it resolves the URL, like for example, if you're importing Lodash, it goes to node modules and searches for the packages, look at package.json and everything, and finally arrives at the index.js of Lodash. That's called a resolution. Once it does that, it goes to the next step, which is loading the file, like reading the file, not parsing it yet. Not too much, and it looks into the imports in that file and recursively does what I just described. We haven't executed anything in the first 3 phases. Then comes the 4th phase where the execution happens bottom up, from the bottom level up to the top. It looks like it's executing it serially, but it's a different way to execute, to module load than CommonJS. What is important for me is these 2, resolution and loading, because module loaders enable us to customize these 2 phases and change them in various ways. And when I gave this talk to Geoffrey Booth, who's part of the module loading group, he said, don't call them module loaders, don't call them module loaders, call them module customization hooks or something like that. Too late, sorry, it's full of module loaders, the whole thing. So I'll stick with module loaders, just so you know this is not the correct terminology. Okay, so let's talk about enhancing the resolution phase. We have the resolution phase and we have the loading phase. Let's talk about the resolution phase. And note, this sample is demonstration code. This is not production code. No error handling, no edge cases, etc., etc. Let's talk about let's write the first a module loader, which helps us override modules. So I can say, instead of A, do module B, or whatever. So let's take main.js. This is the use case, which imports a module to override. It doesn't exist, nowhere in Node modules, nowhere anywhere. So if I run it, what do I get? Error module not found. Makes sense, right? Up till now. So I write an overrides.json, and which says a module to override is actually this module, okay? And I give it module overrides.js, which console logs module overridden. And now, this is the use case. We'll see how to write it in a second. I do node -- import. I give it a register.js, which we'll see in a second, run main.js, and boom, module overridden. The module loader will read the overrides.json and everything. Let's see how to implement that. By the way, if you do -- import, you have to do /register.js. If you do just register.js, where in ESM land, it will think that it's a package called register.js, okay? Okay, so first of all, let's look at register.js. We import module from node column module, and we call a new API, which is module.register. And we give it a URL of the loader itself. The loader is where the loader code is. And it needs a URL, so I take my URL, which is import.meta.url. This is an ESM thing. And I add to it loader.js. This is basically saying the same for a loader as myself, but a different name. Okay? Instead of using __ dir name and __ file name, which is not supported in ESM, I use this trick. Let's look at loader. This is where the money is. First of all, I read overrides.json using fs.read file. Because I'm in ESM, I can use top level await. Not that it's really necessary, just bragging. And then I have a function. I export the function resolve. This is the resolve hook of the loader. And when loading a loader, Node.js looks for that resolve hook. It doesn't have to be there. There are other hooks. But if there is a resolve hook, then that is what Node.js will call during the loading process. So what does it get? It gets the specifier, which is what we are importing from. Okay, import from, and that's the specifier. Context includes more information, for example, the parent URL of the module that is being loaded. And next resolve is, if I don't know how to resolve it, just pass it away to next resolve, and next resolve will know what to do with it. It's basically the default Node.js resolver. So what do? If the specifier is in overrides, what do? Instead of calling next resolve with a specifier, I call the next resolve with the overridden specifier using the overrides object. Very, very simple. If it's not in the overrides, I just call next resolve with the regular specifier, and that's it. And that's it. This simple code really does does an modular overriding. Look at how simple it is to write an overrider which takes the specifier and knows how to look for in other places. For example, PNPM has this one place where all the modules are. PNPM can write a loader that looks for the module in that place instead of the regular node module's location. So really, really, really simple API. Very, very simple, yet very powerful. I want to do one small thing before we continue on to the next loader, which is merge register.js and loader.js in one file. If I do -- import register.js, I want to just do -- import loader.js, okay? So what do? In loader.js, I put in the module.register so that when it's run as a -- import, then it will also register the module. It's simpler to having one file instead of two files, much nicer. So I just do -- import loader.js now, and it works. Caveat, problem, the whole loader API has constantly changed from, I don't know, from version 12 or whatever. It's like running after, but it has stabilized. But Node.js 18, which is still supported, does not support module.register. Instead, so first of all, if there's no module.register, just don't call it. That's easy. And in Node 18, instead of -- import, you have to say -- loader or -- experimental loader to get the loading functionality. Just so you know, but once you have that, you can tell your users, if you're using Node 18, do -- loader. If you're using Node 20 and above, do use -- import. Very, very simple. We won't be showing this preamble anymore in our code. Just assume that it's in all the loaders we will be using. OK, so we saw how to enhance the resolution phase. Let's talk about two loaders that enhance the loading phase. Remember the loading phase? After I resolve the URL, I go and read the file that is in that URL. So let's write a loader that loads from HTTP. Now, I know there's experimental support for loading from HTTP in Node.js, but let's ignore that for a second, because this is an easy loader. So for example, I want this code to work. If I just run it like that, obviously Node doesn't understand HTTP, and we get unsupported ESM URL scheme. But this is what I want. I want the loader to work, and I get ABC because write pad just does a write padding. OK, let's look at the loader. As you can see, it's very similar. It gets URL context to next load. Instead of specifier, it's getting the final resolved URL. But otherwise, it's the same mechanism. We talked about that. And again, if I don't know how to load it, I pass it on to next load. So if it's not HTTP or HTTPS, I pass it on to next load. As you can see, I pass next load, URL, and context. I'm done. Otherwise, I use the built-in fetch. Not very performant, I know. Sorry, Matteo, but hey, this is a demo. I use a fetch. I follow redirects because ESM.sh uses redirects. And I get the text, and I return it as a return value. This is the source code of the file. I've just loaded the file. This is the source code. This is the source format. You can say if it's module or CommonJS. You can return CommonJS code. And you have to pass short circuit colon true. I have no idea why. But if you don't, then it says, oh, you didn't pass short circuit true. And boom, the loader just works. Very, very simple code. Again, very straightforward, not very complicated to understand. And by the way, the API was really complicated back in the days. They've simplified it, and it's still as powerful as it was. Let's do another loader, transpiling TypeScript, just like TS Node does. The previous loader added support for loading from other sources, like HTTP. Here, we don't know where the TypeScript is coming from, but we want to transpile it to JavaScript. So this is the use case. Import A from tsmodule.ts and B from a JS file, and then it should work. So this is the TS file, this is and now I want to run it without a loader. Obviously, Node doesn't know what colon is and doesn't know what TS file is and whatever, so it doesn't work. And if I run it with a loader, which I'm going to implement, it works perfectly. Let's look at the code. I said there's going to be a lot of code. I'm sorry. OK, so load. If the URL ends with .ts, and again, this is a very naive implementation of a TypeScript transpiler. A real TypeScript system would be like, I don't know, 100, 200 lines of code. If the URL ends with .ts, I don't know how to load the file, so I call next load, get back the source, because I know what the return is, and then I transform it into TypeScript. How do I transform it into TypeScript? I use the simplest API possible and the fastest one. I just use ESBuild, transform. It's as simple as that, by the way. It's wonderful. It probably won't withstand production or whatever, like the real life, but for demonstration purposes, this is great. And I return the new source code, and I'm done. Obviously, if the URL does not end with TS, I forgot that, I just call next load and return the result. And boom, it works. We've got transpiling TypeScript. Chaining. Can we chain loaders? Can we do HTTP and TypeScript and blah, blah, blah? And the answer is yes. Let's do HTTP and TypeScript. So I can import from HTTP with a .ts, and all I need to do is chain the loaders. So I have both HTTP and TS. And let's add the override also to make it like interesting. So instead of writing the HTTP here, I just write A and B. And in the overrides, I say what A and B is. If you know what import maps are in browsers, this is very similar to how import maps work. They're very simplified import maps. OK, so how do we run multiple loaders? Easy. We just -- import all of them. Each one of them registers their own module, and we're done. We can just register multiple modules, and boom, it works. Let's see how it works. So let's talk about the resolution phase. So in the resolution phase, only the override loader works, because the others don't have resolve. They only have load. So the specify comes in. The override resolver, if it resolves the URL based on the overrides.json, so it gets the new resolved URL, passes it on to the Node.js resolver. Node.js resolver passes it on, and boom, thread, we're done. Loading, we now have two loaders that implement the load phase, the TS load and the HTTP load. Notice that when I'm importing, let's go back. I'm doing HTTP TS override, but the chain is first TS and HTTP. It works, believe me. Because of the chaining and the next load and everything, they switched the order, but it works. So let's see. I get the URL. TS doesn't know what to do with the URL to get the source code, so it passes it on to the HTTP using next load. HTTP, if it's a non-HTTP URL, passes it on to the Node.js loader, which returns the source code and returns it to TS, and TS transpiles the code, and we are done. So chaining just works. Notice that in some cases, if you switch the order, it just doesn't work. The order is very important in this case. You have to think about it, but it makes kind of a sense in those cases when it doesn't work. Last but not least, and this is an interesting topic, loaders with API, and I will explain. And there was a Chekhov gun in the first day about how to implement caching, cache busting, like hot module reloading. This is it. What I'm going to implement is cache clearing, but it's very, very similar to hot module reloading. So what happens in the following code? If I do await import module.js and then again await import module.js, and module.js has a console log, how many times will the console log happen? Answer? 1. Why? Because there is a cache. Once I import a module, it will not be imported again. It will not be executed again. What is the cache key? And the answer is the final resolved URL. That is important. The final resolved URL, not the specifier. So it doesn't matter what the specifier is. What matters is the final resolved URL. And so what I want is a clear cache between those await imports so that I get the module loaded twice. That's a requirement. And let's see how to implement that. It's not easy. It's not easy. Because there is no API, as we talked about, Matteo said, and others here, there is no API to clear the cache or to clear a specific thing in the cache for various spec reasons, blah, 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 blah. It's just not there. So we have to think of some way. So let's do that. And so this is what we need. We need a clear cache from loader API. That's the API that the user uses. And we need a loader that implements the clear cache. So we have an API and the loader, and they're two separate files. And they're running in two separate use cases, one for the user as an API and one for the loader to implement the clear caching. Let's see how this works. So the idea is this. Every time we add to each URL, we add a query parameter. Remember, we're working with URLs, so we can add query parameters, and they don't affect the final file read. So we add a query parameter, I call it generation. We start with generation 0, and whenever I clear the cache, I increment the generation so that the next time the module will be resolved, it will be generation equals 1. Node will look at the cache, not see it, and reload it. Why is this not really clearing the cache? Because I'm not dispensing with the old version of the module. I'm just loading another version of the module, which is why Matteo, in the first day, said it was memory leaking. It's true. Well, I'm not disposing of that old version. I'm just creating a new version that is reloaded. But let's do that. So in the first thing, we have a generation equals 0. I do an await import. It will be resolved to $gen equals 0. Then I clear the cache, which increments the generation to 1. And the next import, it will be gen equals 1. And from Node's perspective, it's a new module. Question is, how does the loader API communicate with the loader.js? Okay, now this is and the reason it's complicated is because loaders run in a separate worker. They do not run in the user thread. All the loaders run in a separate worker thread, so I can't use global this to communicate between the loader API and why was it it's in a separate loader thread? Lots of reasons. Feel free to come talk to me later about that. I can explain. I don't have a lot of time, but this is what it is. So how do they communicate? And the answer is, how do we communicate between worker threads? We use a message channel. Node 18 does not use separate threads. So in Node 18, you can communicate with global this and do not use message channel, which makes your loaders a bit more complicated because you have to support the two use cases. Unfortunately, hopefully when Node 18 goes away, we can stop with this. But currently, you have to support both Node 18 and Node 20. You can see the examples in the GitHub repo for Node 18. So let's create the message channel. I create the message channel. I get one port for one side communication, another port for the other side of the communication. I store, this is the port. I store the port to loader, the port that I use to communicate. Remember, this is the API. The port to load, I store it so that I can send messages to the loader API. And when I register, I send its data. I can send, during the registration, I can send data to the worker thread. We'll see in a second how it receives that data. And I do a transfer list. I have no idea. It like passes the port to the other side and makes it not useful on this side. If you don't do that, it won't work. I'm sure The cognisanti here will explain it much better than I do. So I increment the generation, clear cache increments the generation and sends the generation to the loader. We'll see in a second how to send the generation to the loader. Oh, there it is. So I do a port to loader post message, and I send it to generation. There's just one message, so I don't do a type thing. How do I get the registration data? Remember when we initialized, we sent the port onto the other? I have a hook in the loader, which is called initialize, which just receives the registration data. So I have the port, and I can on-message and wait for the message to happen. The only message that I get is the one with the new generation. So I set the generation as a global. I read the generation from the data and set the global. Very easy. There we go. Now, we need to add some synchronization because clear cache is synchronous, so we need to wait for the loader to finish its work. So what I do is I don't just post a message. I create a new atomic. I post the message, send that atomic to the message channel, and wait on that atomic to signal that it's done. And the loader stores a new number in the atomic and notifies the lock that it's done, and then we continue. That is how we synchronize between the API and the worker thread. And then in the loader, I just add the query, the generation query, to the URL, and I continue down the loader chain and everything. I just add it. And boom, it works. This trick is used also for mocking modules. This trick of adding query parameters is used in a lot of use cases when you need to play around with the module cache and like import different things and etc. This is how everybody uses it, so this is an important mechanism. Summary. Loaders enhance these two phases. Loaders can be used to load from different resources, transform them, transform the resolved URL, resolve URLs differently. We have initialize to get data from the loader API if there is some, resolve and load for changing the resolution phase and the loading phase. Resolution, we talked about that, gets a specifier and returns the next URL, and it's chained. And loading gets the URL and returns the source, and it's changed. To register loader, we'd use modules.register. Just don't forget it's not used in Node 18. Use -- import or -- loader based on your Node version. You can chain loaders and communicate using message channel or global variables. And the future is bright. We finally have a formal way of doing module loading enhancement, which isn't a hack. It has withstood the test of time. Small changes can still happen, but we're really, really there. It is simple to use and can be used in a wide, large variety of use cases. Thank you very much.
Thank you, Gil, for...
I'm afraid I don't have time, but I will be here till 12, and then I'm flying away, so...
Yes, there's not much time for questions, unfortunately.
Yeah.
So
I'll be here till 12.
So, yeah. Thank you very much for coming. I know everything was tricky, so...
Thank you.
Thank you very much.